Well, today we are going to do chapter 1 of science from class 10. Before we think about force, yes, of course, we think about Isaac Newton. Let me tell you something about Isaac Newton. Sir Isaac Newton was born in the year 1643 and he lived till the year 1727. Sir Isaac Newton, he was an English mathematician, astronomer and physicist. Formulated the laws of motion and universal gravitation. Well, let's go back to our chapter. Yes, well, rain falls down from the sky to the earth. Water flows down the river and ripe fruits fall down to the ground. Anything thrown upwards comes down. Water from the ocean pulled up high during the tides. And the moon revolves around the earth, and the earth revolves around the sun. All these activities take place by the influence of some kind of acting on them. Do you know what's that? Well, you're right. That is force. Such force is gravitational force. Even the atmosphere around the earth exists due to the gravitational force of the earth. Well, let us do gravitation right now. Sir Isaac Newton discovered that there is a force acting in between two bodies which attracts each other. Due to this force, there is a fixed position of the bodies. Such force of attraction between any two bodies is called the force of gravitation or gravitational force. This force depends upon the masses and the distance between the bodies through their center. Well, let's do about Newton's universal law of gravitation. In the year 1687, Sir Isaac Newton performed the law of gravitation. Newton's universal law of gravitation states that every body in the universe attracts every other body with a force called the force of gravitation, in which directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers. Well, let me read again this part. Newton's law of universal gravitation is usually stated as that every particles attract every other particles in the universe with the force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Well, now I want to show you one video clips explaining about the verification of Newton's law of gravitation. Please you watch it very carefully.
Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 times 10 raised to negative 11. What will be the units of G? Force is newtons. As the distance is in meters, we have meters squared. And as the mass is measured using kilograms, we multiply this with kilograms raised to negative 2. This is the value of the universal gravitational constant.
I hope that you have understand the verification of Newton's law of gravitation by going through that video clips. Okay, now we are going to do about the gravity. We are going to read about the gravity and I'll explain you this gravity. You just try to listen carefully. As already mentioned in the beginning of the chapter, anything which is thrown up comes down. Once again I'll repeat you. Anything which is thrown up comes down. Some force is pulling the object down. Yes, of course. Sir Isaac Newton also studied the fallen apple from the tree. The earth has the force which pulls everybody towards it. Center. Yes, such force of the earth which pulls everybody towards its center is called gravity. Please pause down this clip and write down. Force of the earth which pulls everybody towards its center is called gravity. You can write down this in your notebook. Remember what is gravity, okay? So now we want to stop our first part of this chapter 4 up to here. So before that, I'll share you one small joke of the day. So see here, the joke in this joke is that the teacher asks to the students. Teacher said, Isaac Newton was sitting under a tree when an apple fell on his head and he discovered gravity. Isn't that wonderful? Yeah, of course. Everybody feels that wonderful. But what happened, what the answer the students gave to the teacher? The answer is here. Students said, yes sir. If he had been sitting in the class looking at books like us, he won't have discovered anything. Not so interesting, was it? Isn't it? It's so interesting. Anyways, so today we want to close down the chapter here, and in the part 2, in the next chapter, we are going to do about acceleration due to gravity and falling bodies and acceleration due to gravity. Thank you.